Welcome to today's Postgres conference webinar, When Everything Goes Wrong, Incident Response in Large Postgres Databases. We're joined by Chris Travers, Director of IT Operations at Adjust, who will discuss techniques and factors for disaster preparedness, communication strategies between responders for improving outcomes in emergency situations, and communication strategies to other stakeholders during emergency situations. My name is Lindsay Hooper. I'm one of the Postgres conference organizers, and I'll be your moderator for this webinar. A little bit about your speaker. Chris works in Berlin as a database admin in a distributed PostgreSQL environment involving hundreds of terabytes of data in Postgres. He has experience working with Postgres in many areas, from scientific computing in the life sciences to ERP to high-velocity ad tech analytics to geospatial databases. He's the author of a number of extensions in PGXN. So welcome to you, Chris. With that, I'm going to hand it off. Chris, you can take it away.
Thank you, Lindsay. So first of all, I want to thank PostgresConf for arranging these webinars. I think they're great. Any rate, this webinar is called When Everything Goes Wrong, Incident Response in Large Postgres Databases. And we'll be coming back to this picture of this aircraft here because we're actually going to draw some parallels to the sorts of things that happen with aircrafts in distress and even aircraft disasters. So at any rate, I'm Director of IT Operations. I run, among other things, the database teams, the platform teams. I work as a sysadmin, DBA, all kinds of things. I wear a lot of hats. My main responsibility is making sure everything keeps running. And so that's kind of the background of this particular incident. At any rate, our story begins on a Friday morning in January when I was sound asleep at 3:45 in the morning. The phone rang. Answering the phone, I could make out that the person on the other side was from our network operations center, and he was trying to let me know that one of our database engineers needed some help and was concerned about the state of things and would like me to take a look. He read off some warnings that didn't make a lot of sense at 3:45 in the morning. I don't know about you. I'm not thinking my best at 3:45 in the morning. And I was thinking very possibly of going back to sleep, but I thought, you know, I ought to talk to my colleague first. So I got up and checked the messages on Slack, and I noticed that the impact statement, which had not been passed off to me, said imminent major downtime for a dashboard. And so in a moment, I'll come back to that incident, and how it happened and why. But first, I want to take a detour and discuss why I came up with a bunch of ideas for this talk in relation to that incident. Now, this is the same picture as on the title slide. This is a picture of a DC-10. It's an older 3-engine aircraft, 1989. This particular DC-10 was on its way in for what the crew definitely seriously hoped would be an effective emergency landing in Sioux City, Iowa. And I want to draw your attention to the tail here. 40 minutes prior to this picture being taken, this engine on the tail had exploded and sent pieces of metal through the tail. As a result, the explosion itself had taken out one of the 3 hydraulic systems, and the shrapnel had taken out the other 2. The flight crew was left with no normal means of controlling the aircraft, and 40 minutes later, they were on their final approach into an airport with an airplane, sorry, that nobody really understood how to control, but somehow they had managed it. Now you can find a lot of recordings of the actual crash because the crash happened at an airport and people were expecting it. But if you go and you look at them, you wonder, how did anybody survive that? The interesting fact is that a lot of people did survive it, and this story then became one of the great inspiration stories of good airmanship and people working together to solve very serious problems. Um, Interestingly enough, um, so almost 2/3 of the people survived, um, which, I mean, that doesn't minimize the um, loss of life, both to those who lost their lives and to those who lost loved ones. But um, it was really pretty incredible that the team was able to work together to make this happen. Um, the survivors included the entire cabin crew, the entire flight crew, 3 out of 4 of the lap children, the children who were small enough that they didn't even have their own seats, and the majority of the other passengers. So they had done an excellent job of bringing this down, and about half of the survivors might not have survived if um, if it hadn't been for this close coordination that the ground response in particular had. So it wasn't just the aircrew that we need to be thinking about. Um, two um, 2 years after the accident, Captain Al Haynes, who was the actual pilot on the flight, was giving a lecture at NASA about crew resource management, which is kind of what I'm going to talk to you about today in the IT area, but also disaster readiness generally. And he credited the survival rate on that accident to 5 factors. He called them luck, communication, response, execution, and cooperation. Now, the first of these, he said, we all have our personal belief systems, but to facilitate communication, we will call this luck. Um, in other words, people may make sense of this however they will, but the basic fact is that in any emergency, we have some things we can work with and some things we can't, and we don't have any control over that. The other thing that we need to talk about is communication, because all the other things are built on that. Response is built on communication, so is execution and cooperation. And if you can't communicate, none of the rest of those things matter at all. And the fact of the matter is that all 5 of those factors apply to IT emergencies. They're not just aviation accidents. So back to our incident. Postgres, as I'm sure you're all aware, as a relational database, um, has to provide a very strong consistency model. All relational databases tend to center around some variant of ACID compliance, and Postgres is a strong one. And this means, among other things, that when we when we want to execute a query, we want to return an internally consistent amount of data. An internally consistent set of data, because otherwise our database queries would be meaningless. So one thing that we do is we basically set up a snapshot point, and at the point where that snapshot begins, any data that has not been completely written and committed at that point, we're not going to show. In Postgres, we manage this by doing copy of write on all data, and we tag the data with the transaction IDs or XIDs, which both which both write it and also delete or supersede it. So at any given point in time, we can decide or we can deduce from these from the snapshot what data we should be able to show. And these are in XIDs, which are arranged in a logical circle of about 4 billion values. We have cleanup processes like AutoVacuum that rotate that circle. And if you manage to overrun the circle, that leads to data loss, because you can no longer tell what's in the past and what's in the future. So that's a very, very basic overview on the transaction wraparound problem. And yes, we had found ourselves in a situation where transaction wraparound was imminent. A little bit about this database. It was when I started at Adjust, it was a very unimportant, or it was a very important database, but a very uninteresting one. So it was a couple of terabytes, maybe 3 terabytes when I joined. At this point, it had grown to 12 terabytes. It had gone from very little traffic to a lot of traffic, and some of our monitoring and tuning had not really kept up with the database growth, and that's why we found ourselves in the situation we did at that point. Now, our specific problem as a result was that AutoVacuum had stalled for 8 days. And basically, our database engineer in Japan had woken up, checked his emails, goes, that's an awful lot of messages from cron, looked at them again and said, this doesn't sound good, I better wake Chris up. And when I was woken up, we estimated we had 5 hours before Postgres would shut down to try to prevent data loss. Now, 5 hours sounds like a lot of time, but on a 13 terabyte database, 5 hours, you know, these sorts of operations take a lot longer than 5 hours. So we're already in a situation where we're really, really not very comfortable. Now, as I mentioned, luck, I'm going to start off with this. How it could have been worse. Timing of the incident was approximately 1 a.m. UTC when the warning started. And our database engineer had noticed within an hour, despite the fact that our monitoring really hadn't been set up to catch this. What that meant was that we had a significant amount of time between when we detected this and when the problems would start, where we could actually try to figure out what to do to try to preserve as much functionality as we could, and get into that just in a little bit. And finally, the last major part of luck was that it was on a Friday. And the reason why that's important is that our dashboard is under its least heavy use on Fridays and through the weekends. If this had been on a Monday, we would have been under a lot more pressure. But because it was a Friday, we could just kind of, sit back a bit more and be a little more deliberate and not have, not have it be quite as impactful as it could have been on other days of the week. So we also had some important preparedness. 2.5 years prior, we'd had some stability problems on some other databases. And this had made some customers in Asia very unhappy. A couple of them even stopped being our customers. Now, these were later found out to be a bug in some of our custom extensions to Postgres. That bug had been found and fixed long before this point, but some of the institutional changes that we instituted as a result was a direct line to our support personnel for database-related issues. And so the support people could talk to us, we could talk to them. We set up regular meetings with support so that we could keep them aware of the maintenance we were doing and the impacts to customers. And they could provide feedback to us over customer complaints, over performance and things like that. What this really meant on the whole then is it meant that our technical account managers and tech support people were actually used to talking with those of us in operations. And we had a really good working relationship, and this will come into play later as we continue looking at this incident in more detail. And finally, one of the things I really fought for and eventually managed to make happen was having a database engineer in Japan. And we did this initially because we wanted support in Japan to have a contact point that would be up during those hours. But in this particular case, it just meant that we had more hours covered. So when something went wrong, we spotted it much faster. So our preparedness paid off in ways that we hadn't ever really expected it to. When the incident began, we hopped on a call. I talked with Mael, our database engineer in Japan. We very quickly decided that it was going to take, we had less than 5 hours at current transaction usage. I talked with him. We came up with a very basic strategy. I realized I didn't have all the answers that I needed. And so I called in my boss, the VP of infrastructure. And so at 4 in the morning, we're sitting there and we're in a video call and everybody's equal. Maybe my boss is on the call, I'm on the call. The head of database is not on the call, but one of the database engineers is on the call. So, everybody may be in a hierarchy, but on this call, we don't care about the hierarchy. We are sitting there as engineers, and we are sitting there throwing our ideas out and discussing them and collaborating as equals, not as people who report to each other. And that's actually really important because even though people on the hierarchy can overrule things if needed, we're not going to solve this problem with just one person coming up with the answer. So we all need to throw our ideas out. This is then highly interactive. And there's an emphasis on verification. And I'll give it one example of this that we'll come back to in a little bit. But at about 4 in the morning, I asked the question, so when does Postgres shut down? How close can we get to 0 before Postgres actually shuts down? And Mael says, I think it might be 0, but let me check. He goes and checks the documentation, comes back with a figure that says, it says in the documentation 1 million. Robert, my boss, says, can we verify that? And so at 4 in the morning, Mael and I both dive into the C code of Postgres, and we come up with different answers. I see an answer of 1 million. Mael finds an answer of 3 million. So now we have to figure out why we came up with different answers. It doesn't take us very long to find out that in Postgres 13, there was a change made. And the threshold was moved to 3 million because of some corner cases, which meant that 1 million transactions was not enough to clean up transaction wraparound problems. So there's a case where we have emphasis on verification, and a large part of the point is the question of what do we know and what do we not know, and how can we test and prove what we need to do to think about moving forward. So I'll come back to some things we've learned since as we get a little bit further, but that's basically how we acted in this way. So in the first 3 hours, keep in mind, we knew we had about 5 hours. So the point is, how much time do we have left? How close can we get to 0 before Postgres stops writes? Those were important questions. Then the next question is, what can we do to buy time? Can we kill some processes that'll extend this out so we have maybe more time for a vacuum to complete? We didn't know how long the vacuum would take. What happens if we cut out the things that are using the largest number of transaction IDs? Can we use that to buy a lot of time? What will happen? Well, nobody knows. We had to go talk to other engineers. And going out and talking to all those other engineers meant that they knew what we were having trouble with, and we got all the information we needed. And so during that first 3 hours, it was a lot of information gathering. In fact, when you look at aviation decision models and crises, they place a lot of emphasis on information gathering in general. Part of the reason is that you really want to make the right call when you make it. So correct answers were very important as we formulated our plan. And then what we had to do was to reach out to engineers and support and basically communicate the plan outward. What this meant was everybody aware of our circumstance was then willing to work with us. And the communication we set here set the tone for all further communication and responses. So with the teams that we were communicating well with at this point, we communicated well with through the entire incident. For the teams that we missed here, and we missed a couple of them, the communication through the whole incident was not good enough and caused some problems later. And I'll talk a little bit about that. So one of the things I learned to do here, talking about strategies in incident response, is that when you talk with when I talk with a stakeholder now over a current or impending incident, I always say, please brief your team, and I try to go through a sort of a standard review of the facts so that they have it and they can go and talk to their team, and basically we can continue to work together well. So those are two things that I took away from that. Over the next 3 hours, we executed this plan. We gave advance warning to support so they knew what to expect. Um, the developers sometimes jumped in to help out support when they had questions about what customers were seeing. So one of the things we had to do was to stop the service that would read advertising trackers out of one database and write them into this database. And as a result, some marginal functionality on the dashboard stopped working. And they were able to inform support why that was the case and help them communicate to customers that this was expected and all right under the circumstances. What this meant is that those of us who were in the response, in the actual database response, could could prioritize responding to the database issue and just periodically kind of check in on support and make sure everything was okay when we had our time and ability to do so. But we weren't being distracted by requests from support for answers on various things. Um, and so that part was a very exciting part of the incident response, and it actually went relatively smoothly. The rest of the incident, well, it took 36 hours to vacuum the problem table. We had to have somebody paying attention to the database at all times so that we wouldn't lose the database along those lines. This gets back to what Al Haynes says, somebody fly the airplane. You know, when you're in an incident like that, somebody has to keep track of the running systems and making sure that they are continuing to run. So all of your risk factors, you know, you need to have somebody who's actually paying attention to that. And we actually set up shifts and we paid attention to it 24/7 for 36 hours. And it was somewhat ad hoc, but we had, I think, 4 people rotating through that, so it was okay. Um, It can be described as the most boring emergency of all times at that point because there's a very high risk that something can go wrong, but there is very little to do other than keep an eye on things. After the vacuum completed, um, we started restarting services. The developers tweaked some of the workers to write faster. And one of the major things we had to do was to go out to everybody and get ETAs on a full recovery, communicate these to support, make sure that we were, since the incident was really squarely in our shoulders, that we were able to act as the primary point of contact there, and make sure that as customers were asking questions that we could help facilitate answers. In the cleanup phase, we had a number of major communication misses. A couple of our dev teams weren't really aware of the situation fully, and they had some trouble figuring out what to do to recover. This was almost entirely because we did not properly communicate and brief them at the beginning of the incident. So one of the things we learned very, very, very heavily from this incident was the necessity to um, brief all other stakeholders on what the situation is and what the plan is. So, you know, you don't leave somebody out and then have them not able to figure out how to contribute to the success of the response later. Um, and so I'm going to spend a little more time talking about the lessons learned than I have on the other slides. Obviously, there were some immediate shortcomings that were noticed here. We should have been monitoring the number of transaction IDs to wrap around, and we weren't. Apparently, we had tried at one point and failed, and consequently, while we had tried and failed, there was no active monitoring on this anywhere in the organization. So, while we were sitting there on that 20, on that 36 hours period of time, about 30 hours rather, of having to keep an eye on the database, we also went ahead and fixed the monitoring gaps because um, that became an important point of, well, if something goes wrong now, we want to know it now. Um, Another major another major thing that came out of this was the fact that a few of our stakeholders were not prepared and they had insufficient feedback from those of us who were responding. Um, I think there were one or two development teams that really had a problem here, and this was entirely because of missing them on the briefing. Um, and so, this is one of the things we learned immediately to take into account and make sure that we proceed very methodologically going forward, is identifying all of the external stakeholders and briefing them about what the incident actually is, what the state is, what the plan is, and what the impact of them is. Making sure we can answer their questions before those questions lead to misunderstandings in response. The final thing that was, I think, kind of a shortcoming, but it's probably unavoidable when you're in a situation you don't expect, is that we had to make up the priorities as we went along. We decided that we didn't want to take the dashboard down, if at all possible. So we degraded some functionality on it intentionally. Now, having to make these decisions under the gun when you are um, under a lot of pressure because stuff's not going well is a way to eventually sometimes make the wrong decisions. And while in this case, I'm pretty comfortable with the fact that our priorities were pretty well mapped, the fact of the matter is that if we had been able to sit down and map out what was more important than other things, we would have been a lot more comfortable with our decisions during the incident itself, and it would have taken some of the stress off of us. It would have also reduced the chance that this could have ended up going wrong in some ways we hadn't really thought about. So, so those were our major shortcomings. So I want to spend a little more time talking about the strategic improvements. So the incident showed us the need for disaster preparedness, not merely disaster recovery. In our review afterwards, basically what we were able to show is that steps that we had taken in response to previous incidents paid off in unexpected ways. So putting somebody in Japan so that we would have a faster communication with Japanese support paid off because instead now we had somebody who could read messages much earlier in the morning and spot problems before anybody else was in the office. And so, this sort of feedback cycle and sitting down and thinking through what resources do we have, how can we spread them out to be more effective, how can we leverage uh, things a little bit better in terms of what we have where, and uh, that all sort of became much more important. We started actually taking disaster planning in terms of preparedness, not merely recovery, very seriously. Obviously, in a case like this, we had binary backups, but you can't restore a binary backup and solve the problem because the problem is going to exist in your binary backup too, right? So the second thing we really did was we focused very heavily on improving our disaster preparedness plans. And while many of these things didn't happen immediately, we've now started to implement the question of, or the practice of emergency drills. Something's going wrong, we do it on paper periodically. We might even periodically do a live drill where, if we need to shut down a piece of the infrastructure to make sure that we can still handle it, we do that. Those drills are actually really important because they bring everybody together, and then we work together as a team to solve something that's potentially problematic. And then I want to talk a little bit more about this last point, which is crew resource management. And I'll spend maybe a few minutes on this slide as a result. Um, so the last thing that came out of this was that we had a few more incidents later on in February, actually, where we did not collaborate as well. And in reviewing these, it became very clear that while this particular incident was well managed, a few other ones were not as well managed. And that we had trouble with communication and coordination along the way. And so what we actually did was we contracted with a company that does crew resource management training to aviators, hospital staff, and train operators, and asked them to come in and teach us. That sounds like kind of a funny combination, but the thing is that these are all safety critical fields, right? And the goal of crew resource management is for the flight team in an airplane or the including the cabin crew and the or the hospital staff to be able to come together and collaborate where the stakes are much higher than anything we deal with, right? If I mismanage an incident, maybe people lose money, maybe a lot of money. But if a surgeon mismanages an incident, maybe a patient dies. There's no question about which of those is a greater impact. And so getting experts in to teach us about managing our resources when lives are on the line helps us when we're reacting even where it's just money that's on the line. And so what we did was we looked around, we found this company, we hired them, and they came in and they gave us a crew resource management training. The first we divided for the responders into 3 different repetitions of 2 days. So some people take one or another. And for the management, a 3-day course. And the benefits on that were way, way, way in excess of anything I had actually expected. I expected that going into it, we would get a lot of coaching on how to communicate effectively and how to communicate across power levels, which we did. And this is very important in improving our incident response generally. But we also got things like how to divide up tasks so that people don't get overwhelmed, and the importance of managing stress. What happens if you don't manage stress? How to maintain situation awareness and what happens when people get overwhelmed, and how to recognize these things so that if somebody's about to do something stupid, you can jump in and say, hey, wait, I think that's a bad idea. Here's why. Um, can we try this instead, or let's sit down and try to make a decision. And the final piece that we got was something that we have also implemented, which is a structured decision model. Now, different airlines, of course, use different decision models. But the structured decision models out of crew resource management are now being implemented in many different places. And they are extremely helpful in reacting to emergencies. The one we've standardized on is British Airways' model, and that goes by the acronym of TDODAR, which is time, diagnosis, options, decision, act or assign, um, and then review, and then it can go back up to the top if the problem's not resolved. So you can ask, okay, now how urgent is it now that we've done that, and so forth. And if we had been using an urgency-based model like this, this would have certainly reduced our stress level on this. And stress is actually something that helps make people make bad decisions, and so it's something that's really good to avoid. So I would actually say of a lot of these things, whether you study it on your own and decide to try to implement it in your organization, one of the top things to do is to actually study crew resource management techniques, concepts like power gradients and how do people communicate with superiors and direct reports and things like that. And how do you build a collaborative environment so that when things go wrong, that everybody's comfortable throwing their ideas in and they know that they're not going to be ridiculed if somebody thinks it's a bad idea. So those were all things that were greatly clarified for us in the crew resource management training, and that this was something that I think was a massive success out of this. So my overall assessment on this is, while our response was definitely not perfect, it was definitely within the zone that I would want to see every time. I think it was definitely excellent. We had a few areas that we missed, but I mean, you know, if if you're not really prepared and something goes wrong, you're going to miss some things every time. So, on the whole, I have to give us, at least a solid 8 or 9 out of 10. Um, and if we could manage every incident this well, I would be quite happy. And finally, it shows the importance of planning and preparation and making sure not only that you're communicating well in an incident, but that you've built all the right working relationships across a company so that when you have an incident and you go to somebody and say, we're having a problem, here's what's going on, and here's what you can expect from it, they know what you're talking about, they know how to talk with you about it, and you're able to collaborate on a solution. So on that day, I think the really big accomplishment and the reason why I would give us a good score on that is that we moved together as a company, and the other responders deserved a major shout out. The development teams that helped us out, answering questions from support of, oh, why is the dashboard hanging when people click on this button? That was really helpful. Our technical support was faced with a terrible situation in that certain things were not going to work, and they had to communicate the bad news to customers, and they did an excellent job. Partly because I think we made sure that they had all the information they needed, and they were able to communicate it. Management was very supportive, both on getting out of the way when necessary, and also getting people out of our way. And finally, I want to thank everybody who's attended this talk. Uh, this is this is an important topic, and while it's very hard to come up with a definitive guide for exactly what to do and what not to do, uh, learning to be more prepared for emergencies is one of the things that's at the core of what we should be doing as IT professionals. So I want to thank all of you, and now I think I will take questions.
Awesome. Just awesome. I feel like this presentation could apply to so many things. So thank you so much. We currently have 3 questions. So if
Mhm.
anybody has anything lingering, go ahead and get it into me now. So starting from the top, and I was having the same thought when this question came in. How did you baseline in the initial meeting such that the quote unquote hierarchy flattened to begin solving the problem?
That's a really great question. Um, so in this particular case, we had a really strong collaborative working relationship ahead of time, and this is really important. This is why I say this can't really start in an emergency, right? We had Mael knew very well that if he told me he thought I was wrong about something, that I would listen to him. He knew that if he told Robert he thought Robert was wrong about something, Robert would listen. After all, I knew Mael knows Postgres probably in some respects as well or better than I do in some areas, and maybe I do better than him in some other ways. But making sure that you have that respect going into into the situation is critical before you can um, uh, before you can flatten it. And then at that point, you just simply say, okay, we're collaborating as engineers. Let's toss our ideas out.
Awesome. Thank you. Do you have suggestions or resources for preparedness plan formats?
That's another great question. So what we did was we didn't really work from many sort of ready built formats on our first draft, and we're in the process of kind of going back and reviewing this and trying to decide what to do to improve things on a second time around. What we're doing is we're looking at what we can find from civil authorities, primarily because the civil authority plans tend to be very detailed, and they tend to have a lot of they tend to have a lot of risks laid out very well. There are some other frameworks. I think ITIL has some aspects of trying to manage risks and things, but there's a difference between sort of a risk management plan and a disaster preparedness plan. And if you go and you listen to the Al Haynes NASA lecture, which was in like 1991, he talks about what the Sioux City Airport had done, and what they had done is basically they'd run a drill, I think the previous year, where an airliner crashed on the same runway that they actually crashed on, and they had 100 survivors on it. And what they did was they ran through this as a live action drill, pretending that there was an actual airliner there, even though there wasn't, and basically found out that they had a lot of deficiencies in resources. And this was one of the things that they addressed. And so one of the things that I think needs to be in the plan is some sort of a drill strategy, whether it's a paper drill or a if you will, kind of like a get together and how would we deal with this if it happened, meeting once a year or once a quarter or whatever, or whether it's an actual live training or a live action drill. um, there needs to be some scheduling of that in, because otherwise it's a little bit harder to justify to people why you're taking time off from building stuff to temporarily break stuff.
Thank you. And finally, could you say a little bit more about what your platform meetings consist
Yeah.
of?
So I assume these are the meetings I referred to with the support between platform and database and a lot of the rest of this. And basically, these came out of a time when we had a performance problem on some of our analytics. And just as a technical discussion of what had happened, we had a custom date time type that we had written to save some bytes, and there was a typo in the extension SQL file that loaded the wrong selectivity operator, and consequently the planner would scan the histogram backwards. And consequently, at the end of the month, what would happen is not all values would be in the histogram, and it would start choosing the wrong indexes and things like that. So what we've done in the resulting fallout of that is we'd set up these meetings with platform and database and support, and basically we would go around and we do basically three things. We would go around first from the platform and database side, and we would give updates on any maintenances we were planning and what customer impacts we expected from those maintenances. So it could be something like, we need to add a bunch more shards to our sharded analytics system. We don't expect any problems, but here's some things that we could imagine possibly happening. So we could actually go through a risk assessment with support, and if support says, we have some problems with this, then we could rethink. Then the second time around would be support basically going through groups of customer complaints over reliability and performance issues. And it was limited to those because obviously if there are new features that people want to request, then that has to be owned by product and has to go through the roadmap process. But if it's, oh, this isn't working, then we wanted to hear that directly from support. And so we would get all of the complaints over what wasn't working. We would take those down as notes. We would discuss with support then on the third time around what we wanted to do about it. And then we would go back and execute and come back to the next meeting, which initially was every week, and then we moved it to every month once customers were starting to get happier.
Fantastic. Well, those are the questions we have. Chris, thank you so much. This really was illuminating. Truly, I feel like I am walking away with some strategies that I'm going to go implement. So once again, thank you. And to all of our attendees, thank you for joining us. So regardless of where you are and what time it is, I hope you have a great rest of today. And I will see you on future Postgres conference webinars.
Thank you.